So you recall what our first order differential equation, how we look like. So we have a first order, so y prime. So we have y. We have some coefficient here, say a1x. So that coefficient should not have anything with y. I'm going to have a0x here. And maybe some function, I don't know, f of x. Right? So that's how potentially it might look like. We want it to be, it's in the standard form. So standard form. Standard form is going to have coefficient of y prime to be 1. Then we're going to have hxy equals to, say, g of x. Okay, so that's standard form. And that's one we're going to be working on. So we're going to be solving first order linear differential equation in the standard form. Okay, so if needed, divide by coefficient of y prime basically, and that's it. Okay, so before I do that, let's notice the following. So if we have, if I have e and raised to function f of x, and I want to take its derivative, that is going to be chain rule. So I take in derivative function, and then multiplying it by derivative outside. Outside function is exponential function, e to a u, and our derivative e to a u is e to a u. So that's chain rule. So in particular from here, if I take y times e to the f of x, that is going to be equal to, so derivative first, times e to the f of x plus y in derivative of f of x with 1, which is with e to the f of x with 1, which is no. Right? So in particular, we can factor here e to the f of x. So y prime plus y times f prime x. To make connection this with that. Okay, so if I try to make that connection, then you see that if I try to do that connection, that h of x is going to be essentially my derivative of f prime. Right? And we need e to the f of x to multiply by. Do we see that? Okay. If we see that, then let's rewrite. So we're assuming that h equals f prime x, so which means fx equals to integral of hx dx. So we multiply by e to f of x. So y prime plus h of x y equals e to f of x g of x. Okay, so I did it for this guy, and I multiplied by e to f of x, both sides. Okay. Then the good thing about the left side is going to be this guy. So left side is going to be derivative of y times e to the f of x then y times e to f of x is going to be equal to integral e to f of x times g of x. And basically will be done if we can find that integral. Okay, so let me maybe write down one more time, a little bit shorter, because right now I provided everything with some intuition on what is going on here. But now maybe the steps a little bit more with direction and how you expect it to work it out. So we start with something which is given to us in the standard form. Y prime plus h xy equals to g of x. So that is given. That's the one which we need to solve. Okay. Then our steps. First step is find f of x, which is going to be antiderivative of h of x. Then second step, multiply everything by e to the f of x. Okay. Then the left side will be derivative of e to the f of x times y. Keep the right side. And the last step is y times e to the f of x. We take an antiderivative. It's going to be equal to antiderivative e to the f of x gx. 3 steps. E to the f of x is called integral factor. We're going to call it integral factor. Okay, so we're going to do 3 steps. Okay. So are we comfortable? Y prime minus 3y equals 0. So h of x, so solution. H of x here equals -3. So f of x will be antiderivative of -3 dx, so -3x. And integral factor is going to be, so integral factor is going to be e to the f of x, e to the -3x. So e to the -3x times y prime minus 3y equals to 0 times e to the -3x. We can check that, but derivative of the left side is supposed to be derivative of e to the -3x times y. You can check that. Okay, so just for curiosity, maybe at least once, let's check it somewhere on the side. If I take e to the -3x times y, I'm doing product rule. So derivative of -3 e to the -3x times y plus e to the -3x times y prime. Factor e to the -3x out. So we're going to get -3y plus y prime. And that's exactly what is written here. You can match it. So again, that's the side comment. Let's see what you probably want to do it once or twice for yourself, just to make sure you know why that method works. But otherwise, down the road, we'll just be running through it and just say that's derivative of product. And then taking antiderivative, we're going to get e to the negative 3x y equals antiderivative 0 dx, e to the negative 3x y equals to constant, so y equals e to 3x times constant. First derivative minus 2y equals to 6. So I'm going to give you a minute or two to figure it out. So basically figure out what f of x is, e to the f of x is, then equals something times 6, and get your answer. So find your integral factor. So first define f of x. Okay. I'm guessing the solution is supposed to be negative 3 plus constant times e to the negative 2x. I forget, that's my guess. So our f of x will be antiderivative negative 2 dx, so negative 2x. So integral factor will be e to the negative 2x. So we multiply both sides by e to the negative 2x, so we're going to get e to the negative 2x times y prime minus 2y equals 6 times e to the negative 2x. Then the left side is supposed to be derivative of e to the negative 2x times y. And the right side, I just copy it. Then e to the negative 2x times y is supposed to be antiderivative of 6 times e to the negative 2x dx. 6 is a constant. Antiderivative e to the 2x is e to the negative 2x over 2. Okay. Guess now arithmetic here. So let me write it one more time. So e to the negative 2x times y equals negative 3 times e to the negative 2x plus c. Multiplying everything by e to the 2x. So we're going to get y equals negative 3 plus c times e to the 2x. I guess I still did a typo here, right? It's supposed to be plus, not minus. Better? Let's solve this one. xy prime minus 4y equals x to the 6 e to x. You can solve. I'm going to give you a second to realize that you have to do here a preliminary step, right? Because you notice that coefficient of y prime is not 1. So we have to adjust it to make it into standard. So don't forget that the method we are doing is for standard. So here, don't forget to do preliminary step. And do that. So don't forget to do it. Then find integral factor. Which is e to f of x. So I'm going to give you a minute so try to figure it out because it's going to involve some property of log and exponential against functions. Again, setup is the same. It's just your calculations a bit confusing here because it's going to involve some algebra work here. So let me try. So integral factor. So I calculated f of x. So it's going to be antiderivative of negative 4 over x dx. So negative 4 ln x. So each of integral factor is going to be e to f of x. It's going to be e to negative 4 ln x. So e to ln x, then to negative 4. So x to a negative 4. So that's my integral factor. Okay. So I'm taking x to a negative 4. I'm going to multiply it by y prime minus 4 over x y equals x to a negative 4, x to 5, e to x. So I'm substituting it, I'm multiplying that one, multiplying by x to a negative 4, right? By integral factor. Then if my calculations are correct, then I don't have to worry about the left side. Left side is supposed to be, I don't even have to do much about that. Left side is supposed to be derivative of x to a negative 4 times y. I don't even have to distribute anything to the left side. But I know I should know that derivative of x to a negative 4 times y is supposed to be on the left side. All right side, I will work on it. I'm going to get x times e to x. Then take an integral of both sides. X to a negative 4 y is supposed to be equal to integral x e to x dx. This guy, integration by parts. You remember integral u dv equals uv minus integral v du. Okay. X to a negative 4y. So if I do that here, then I'm going to be choosing u to be x, v to be e to x. So u prime equals to 1, v prime equals to e to x. So if I do that, I'm going to get u times v is going to be x times e to x minus integral e to x dx. So x to a negative 4y equals x e to x minus e to x plus c. Multiplied by x to the 4 to get rid of coefficient of y. So we're going to get eventually y equals x to 5 e to x minus x to 4 e to x plus c times x to 4. Okay, so let's try another example. X squared minus 9, y prime plus xy equals to 0. Solve. So the good thing about this type of equations, at least here, is you have 0 on the right side. So when you multiply by integral factor, you still have 0 on the right side. So it will be really easy to integrate the right side. So you don't have to do anything. Basically, you're going to get C on the right side. So basically, all that you have to do is just find your integral factor, and basically we'll be done with in a second. So it's going to give you a minute to work on it. So if I'm correct, the integral factor is going to be square root of x squared minus 9. Are we getting that? We need to provide details. So basically, in great shape. Multiply by x squared minus 9 and the square root. Zero stays 0 on the right side. Then you know where left side will be derivative of square root of x squared minus 9 times y. So x squared minus 9y equals to constant. So y equals to constant divided by square root of x squared minus 9. Anyhow,